A brief history of the digital revolution. It actually started in the 19th century. Charles Babbage attempted to build the Analytical Engine, a mechanical general-purpose computer for complex numerical calculations. Ada Lovelace collaborated with Babbage. She was the first to propose the idea of the computer algorithm, or just known as a program, and also saw that computing machines could be used for more than just number crunching. Babbage's Analytical Engine, seen here, was very expensive and it was unsuccessful. The mechanical parts required highly skilled craftsmen and was very hard to put together. With this failure, Lovelace's ideas had to wait until they were rediscovered in the 20th century. Samuel Morse, an artist by trade, developed the concept of the single-wire telegraph and Morse code, the means by which text could be sent using combinations of short and long electrical pulses. The telegraph was a major success. It enabled rapid communication between distant towns. It was much faster than the competition, which were express horse riders or carrier pigeons. Morse code provided the model for translating information into a simple code that could be transmitted clearly, then stored and processed. The idea of a simple code was critical in developing digital technology. And the code just means we're assigning short and long pulses to various letters and numbers. So if you had a short electrical pulse followed by a long electrical pulse, that would represent the letter A. If you had two short pulses and one long, that would represent the letter U. Now, we said short and long, but let's clarify that. Let's quantify it. The dot, the short pulse, is 1 unit in length of time. The dash will be 3 units, 3 times as long. The space between letters will be 3 units so you don't confuse them. And then again, for the same reason, the space between words is 7 units. On the previous slide, we said units and we didn't say seconds. It's because the speed of the operators was different. If you were very, very quick, you could do it a lot quicker perhaps than the dot being 1 second. Maybe it was only half a second. So let's say it was half a second. How long would the dash be? That would be 3 times that, or 1.5 seconds. So please look at this message here and pay attention to the spacing, right? There's big spaces here, so that probably indicates another word, right? Please decode that using the Morse code below and move to the next slide for your answer. Okay, here's the answer, and what we have, this letter is C, then you have a space, then O, D, E, then you have a bigger space which says there's another word. So you have I, S, and let's see, I've memorized these and this one. I know alpha too, well that's not up there. And then what we have, this is F, this is U, and this would be N. I think alpha is the exact reverse of that. It would be a dot and a dash. Let's check that out. Hey, I got it right. The digital revolution really got going during World War II, between 1939 and 45. Then throughout the rest of the century, there were many brilliant ideas and inventions that were critical to the development of modern digital technology and this whole unit topic, the mobile phone. There are 5 individuals who provided the most foundational ideas and inventions for modern digital technology. Claude Shannon was an American mathematician, electrical engineer, and cryptologist. He's considered the father of information theory. He invented logic circuits that became the foundation of modern digital computers. He also developed ideas for digitizing the analog signals, which would remove noise and also provide a more secure communication. Alan Turing was an English mathematician, computer scientist, cryptologist, and theoretical biologist. What a group of tremendous stuff. He is considered the father of computer science and artificial intelligence. He further developed the concepts of the algorithm and computation with the Turing machine, which was the model for a general-purpose computer. In 1947, the Bell Labs team of John Bardeen, William Shockley, and Walter Brattain discovered the transistor. The transistor is a device made from a sandwich of semiconductors. Semiconductors are between a conductor and an insulator. They can be used as a switch or as a power amplifier or current amplifier. As a switch, the transistor is the building block of all modern computer processors, memory, and storage, and your mobile phones. Bardeen, Shockley, and Brattain received the Nobel Prize in Physics in 1956 for their work on the transistor. We focused on some of the key people whose discoveries led to the digital revolution. Obviously, there are so many other important contributors whose discoveries and inventions are far too much to cover in a short presentation. Please check it out and learn more. There are many fascinating books you can read about the digital revolution, cryptology, which is a fancy word for secret codes, information theory, and computer evolution. And you can also read about the inventors and scientists and their relationship to critical events in history. So, now let's move on to the technical business of how digital signals are created, communicated, stored, and processed.